Okay, I don't know what happened. So back to the questions. So we have a function from R to R, a piecewise function, okay? And we are asked to find the limit to minus infinity and plus infinity, right? Okay, but we begin with the last one, right? Okay, write an equation of the tangent line to the graph of f at the point whose y coordinate is minus ln of 2. Oh, okay, we have to see where minus ln of 2 is on those two, right? Well, what about we do minus ln of 2 equal to ln of, sorry, sorry. So that's ln of 1 plus square 2, right? So we can do this, right? 1 over plus x2. We cancel the ln's, and x will be plus or minus 1, right? So since this is for minus than 0, that will be x equals minus 1. Okay? Okay. Minus L1, ln of 1 minus ln of 2, ln of 1 dividing x squared. All these steps, right? And we got here, right? So the point will be minus 1 minus ln of 2, right? And since they are asking for the tangent line, I have to take the derivative to find the slope, right? And then plug in the values. Write an equation of the tangent line to the graph of f at the point whose y is minus ln of 2, so we know that x is minus 1. We just have to find the tangent line. So first we have to take this derivative, right? So that will be 1 plus x2, the derivative dividing 1 plus x2, right? So that will be something like minus 2x dividing 1 plus x squared dividing 1 plus x2, right? So that's minus 2x dividing 1 plus x2. Dividing is the same as multiplying, right? We can cancel, and we get minus 2x1 over x2, right? Since we are on f minus 1, that will be 2 dividing 2, that will be 1. Okay? Okay, so m will be 1, right? M will be 1. And now we just have to plug in the values, okay? So y is minus ln of 2, x is 1, this is minus 1, so b will be equal to 1 minus ln of 2, so that will be the tangent line, okay? 1x, of course, we're not going to write this, right? We'll write x plus 1 minus ln of 2. Okay, now we go back to question A, the limit to minus infinity and plus infinity, right? So the limit to plus infinity, that will be e to the power of minus 1 over x dividing x. So that's 1. This should be plus infinity, not an x here. Okay, that's the same as this. So 1 dividing infinity is 0, right? This is 0, e to the power of 0. That will be 1 dividing plus infinity, that's 0. Okay, so the first limit is 0. Now to minus infinity, we have ln of 1, 1 plus x squared, minus infinity to the power of 2, that will be plus infinity, 1 plus infinity, that's plus infinity, 1 over plus infinity, that's 0 by the right side, plus, so that's ln of 0 plus, so that will be minus infinity. Okay, so this is the right. We are really terrible at this. Okay, so that's simply ln. Okay, this is value 1, right? 0 plus, this is 0, so the function goes here to minus infinity. Okay, so next question is, show that f is continuous in R. Okay, at the right side of 0 the function is continuous, since it is a division between an exponential and a polynomial. Both are continuous. The division of two continuous functions are continuous. And on the left side, at the left side of 0, it's a logarithm function, and these functions are continuous. Okay, so our problem will be the 0 point, right? So f of 0 will be ln of 1, that's 0, and we have to take the limits, both the right and the left limits. Okay, so limit when x goes to 0, the left side, that will be ln of 1 dividing 1 plus x squared, 0, 1 plus 0 plus, that's ln of 1, plus, right? So ln of 1 is 0. Okay, so f of 0 is 0, and ln of 1, the limit on the left side, is 0, 2. So the right side limit is this funny limit, e to the power of minus 1 dividing x. Okay, we have an indeterminate here, right? 0, that's infinity, minus 1 dividing 0 plus, that's minus infinity, right? That goes to 0, and this one goes to 0. Okay. Oh, okay. It's pointless to take Cauchy, right? To use Cauchy theorem here. Because here you get 1, but on the top you get e to the power of minus 1 over x dividing x squared. So you did not solve your problem, okay? So we did this, we changed variables, okay? We said that 1 over x is the same as y. So the limit here is for 0 plus, that goes to plus infinity, right? So this has to be plus infinity, so we have to put plus infinity here. Okay, limit when y goes to plus infinity, 1 over x is y, 1 over x is y, so e to the power of minus y, and x is 1 over y, not a minus here, there is no minus here. Okay, x is 1 over y, so they switch, right? One goes to the top and the other one goes down. Oh, now we have infinity dividing infinity, another indeterminate, right? Here we can use Cauchy. We take the derivative, right? Derivative of y is 1. The derivative here is e to the power of y. So that will be e1 dividing e plus infinity, 1 dividing infinity, that will be 0. Okay. I think it is continuous, right? The left limit, the right limit, and f of 0, they are all 0. So we are using this definition, right? The function is continuous if and only if continuous at point x equals a, right? If and only if f of a, limit on the left and limit on the right is the same. So in our case it was on point 0, 0, 0. This is 0. We got 0 here and we got 0 here. So the function is continuous in R. Now we have this without additional calculations, justify the following statements if the following statements are true. Have as a maximum m and a minimum m in any interval minus a, where one is positive and the other one is negative, right? Okay, in the previous question we proved that f is continuous in R, right? And since m is a positive value and m is a negative value, we can call one f of a without loss of generality, of course. And m is f of minus a since the interval is symmetric. Now, using Bolzano, Bolzano says that if one image is negative and the other image is positive, since the function is continuous, there will be a point C in the interval, somewhere in the open interval, where the image will be 0, right? But this is an equivalence. So if this exists, that's the case because we proved in the previous question that f is continuous in R, and in the previous question we proved that f of 0 is 0. So for sure, the implication now will be this one, okay? So for sure, in this direction, that there will be a image, a positive image and a negative image. Last question. We have to prove that there is a C positive where the derivative is 0. Well, we can use the Rolle theorem, right? The Rolle theorem says that between two zeros, between two zeros of the function, there is at least one zero of the derivative, and between two zeros of the derivative, there is at most 1 zero of the function. Okay? So with these corollaries, right? Between two zeros of the function, there will be at least 1 zero of the derivative. There can be more. Okay? And between two zeros of the derivative, there will be at least 1 zero of the function. So we can use Rolle theorem, or this theorem, the theorem of zeros, whatever title. There are lots of titles for these sort of theorems, and prove that. Okay? And next video I'll jump to the next question.